In this video, we'll understand the concept of equation of a line. So in this chapter, you'll be given some points and based on the given conditions, we have to form the equations. Now, before we go to the concept of this chapter, there are a few concepts that we need to revise from the previous standards. So, for example, this is my Cartesian plane. This is our x-axis, this is the y-axis. X-axis is also known as abscissa and y-axis is also known as ordinate. Now, let us say we have a line passing through both the axes. So we have a term here called inclination. Now, inclination is the angle made with the x-axis in the anti-clockwise direction. Remember, the word anti-clockwise is very important. So the angle made by the x-axis in the anti-clockwise direction is called the inclination or the theta. So this inclination, when we use this inclination for slope, that is m, slope of this line is equal to tan theta. The word slope is also used as gradient. So if you see somewhere gradient as the word, consider that as the slope only. Now, in case theta is not given to you, but you are given 2 points of this line, let's say x1, y1 and x2, y2. These 2 points can be anywhere on this line. So, in case theta is not given to us, we can still find the slope by the formula y2 minus y1 upon x2 minus x1. So for example, the value of theta is given to you as, let's say for example, this is the line and this is the theta in the anti-clockwise direction. So if theta is 45, so the m, that is equal to, m will be equal to tan 45, that will be equal to 1. Similarly, if it is 30 degrees, it will be 1 by root 3. If it is 60 degrees, it will be root 3. So, based on the value of theta, you can find the value of slope. In case theta is not given to you and you are given any 2 points on the line, so you can use the formula y2 minus y1 upon x2 minus x1. Now, there are a few concepts of parallel lines, perpendicular lines and collinear lines. In case two lines are parallel to each other, then if this line has the slope m1 and if this line has the slope m2, so in case of parallel lines, m1 is equal to m2. The same concept is applied for the collinear points. If there are 2 points, so what are collinear points? Collinear points are those points which lie on a same straight line. So if I have here, let's say this. So this A, B, C are collinear points. Now if slope of AB is m1 and slope of BC is m2, if m1 is equal to m2, then we say the points are collinear. The third case is perpendicular lines. In case of perpendicular lines, for example, there's a line here which passes from this one and is perpendicular. In case of perpendicular lines, m1 into m2 is equal to minus 1. This is called the case of perpendicularity. So, in case the lines are parallel, it will be m1 into m2. In case the points are collinear, again m1 is equal to m2. In case the lines are perpendicular, then m1 into m2 is equal to minus 1. So sometimes in the question you'll be given a line and you'll be asked to find the slope or the equation of the line which is parallel to it or perpendicular to it. So these conditions will be used there. Next concept is intercept. So if you see this point, let's say P. This point P is at some distance from the origin. Origin is our 0, 0. So this distance of this, when the line cuts the y-axis, so the distance between the y point and the origin is called the y-intercept. We denote it with C. So this distance where the line is cutting the y-axis, this distance from the origin is called the y-intercept. This distance is called the x-intercept. So this is the slope, this is the y-intercept. Now using these concepts of slope, intercept and the points, we will find the equation of line. Now there are three ways in which we can find the equation of a line. The first is called the slope intercept form. So for example, you are given the value of slope and you are given the value of y-intercept. Then we can find the equation of line using the formula y is equal to mx plus c. Here the coefficient of x is the slope and the constant part is the y-intercept. Next is, in case we are given just one point and the slope. So we can use point slope form to find the equation. So the point slope form will be y minus y1 is equal to m into x minus x1. So using this formula, we don't need second point. If we have slope and one point, then in that case, we can use y minus y1 is equal to m into x minus x1. In case we are not given this slope, we are just given 2 points, that is x1 y1 and x2 y2. In that case, we can use 2-point form. And we can find the equation of the line using the formula y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. If you see this closely, this is very similar to this one, only instead of m, we have to find out the slope now. Now, remember in the exam, the points that you take x1, y1 for the slope, the same points you have to take for x1, y1 as the point. So we can, if we are not given the intercept, if we are not given the inclination, we can directly use 2-point form as y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. If you get confused with this one, you can simply using this x1, y1 and x2, y2 get the value of m and then go for point slope form. So in this way, you can use any of these three formula and you can calculate the equation of a line. Now let us have a question to understand this concept better. Now this question will cover almost all the concepts that we have learned so far. The question is, A, B and C are the vertices of the triangle ABC. Find the equation of the median of the line through A, altitude of the line through B and the line through C which is parallel to AB. Now always whenever you are doing coordinate geometry, first try to draw the figure. When you draw the figure, it becomes the question, you start understanding the question better. So here we have a triangle ABC. A is 1 comma minus 5, B is 2 comma 2 and C is minus 2 comma 4. The first part is to find the median of the line through A. So it starts with A, goes here at D and the median, the purpose of median is to divide the line segment in two equal parts. That means D is the midpoint of BC. We have already learned in the previous chapter how to find the midpoint. So midpoint is x1 plus x2 by 2, y1 plus y2 by 2. So if we do that here, that will be 2 minus 2 by 0 by 2. So that will be 2 minus 2 by 2, that will be equal to 0. And 2 plus 4 which is 6, 6 by 2 is 3. So 0 comma 3 is my coordinate for D. I have to find the equation of line through A. Now, if when I have to find the median, we have to find the median of the line through A, that means I have to use these 2 points. We can go for 2-point form easily, or we can find the slope and go for the point slope form. We'll directly go for the 2-point form. So y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. Y as it is, y1 we are considering as this one. So minus of minus 5, that will be equal to plus 5. That we will do it later. Y2 minus y1. So y2 is this. So 3 minus of minus 5. So I can directly write 3 plus 5 upon x2 minus x1. So 0 minus 1 into x minus 1. So we'll just simplify this. This will become y plus 5 is equal to 8 upon minus 1 into x minus 1. We can shift this minus upstairs, on the numerator side. So it becomes minus 8. Just simplify it. Y plus 5 is equal to minus 8x plus 8. Get this on this side. So 8x plus y is equal to 8 minus 5, that is equal to 3. So this is the equation of the median through A. The second subpart is altitude of the line through B. So altitude of the line through B, this is perpendicular. We learned that the condition of perpendicularity is m1 into m2 is equal to minus 1. So for that we need the slope of AC. So m1 will be equal to y2 minus y1, that is 4 minus of minus 5, that is equal to 4 plus 5. y2 minus y1 upon x2 minus x1. So minus 2 minus 1, which is 9 upon minus 3, which is equal to minus 3. We know that for perpendicular lines, m1 into m2 is equal to minus 1. So minus 3 into m2 is equal to minus 1. Minus minus gets cancelled. This implies m2 is equal to 1 upon 3. So slope for, let's say this is BE. So slope for BE will be equal to 1 upon 3. We have this point 2 comma 2. So we can directly apply point slope form. So that will be y minus y1 is 2 here is equal to m into x minus x1. We'll just simplify this. 3y minus 6 is equal to x minus 2. We can again just rearrange them again. So that will be equal to minus 6 plus 2 is equal to x minus 3y, or x minus 3y is equal to minus 4. You can take this minus 4 on this side as well, so that's also fine. You can rearrange them as you like it. So x minus 3y is equal to minus 4 is the equation of altitude of the line through B. In the third case, that is find the line through C and parallel to AB. Just making a correction here. The line through C parallel to AB. A line through C parallel to AB. So if I say parallel to AB, that means this line will have slope. Let's say this line is L. So this line L will have the slope same as this line AB. So let's just do that. M is equal to y2 minus y1. So 2 minus of minus 5, which is equal to 2 plus 5. y2 minus y1 upon x2 minus x1. So 2 minus 1. This is equal to 7 upon 1. So this line L will also have the slope as 7. Again, we can go for the point slope form, that is y minus y1 is equal to m into x minus x1. So this is minus of minus 2, so it will be plus 2. Just simplify it further. Y minus 4 is equal to 7x plus 14. Just take everything on the one side or just constant on one side. So it will be 7x minus y is equal to minus 4 minus 14 will be minus 18. So this is the equation of the line through C and parallel to AB. So in this way you can do more questions from your textbooks and the reference books. This chapter is important from your 10th, 11th both perspectives, and also very easy chapter. You just need to apply the formula, remember the concept, and you will be